Hello and welcome to another episode of Tag1 Team Talks. I'm your host, Preston So, Editor-in-Chief and author of Decoupled Drupal in Practice. I am joined today by three of my wonderful friends who are going to talk with us about WebRTC and some of the amazing applications that we can apply to it, including Yjs and collaborative applications in a peer-to-peer setting. I'm joined today by Kevin Jans in Germany. Kevin is the founder and the project lead of Yjs and the real-time collaboration systems lead at Tag1. We're also joined today by Fabian Franz in Switzerland, senior technical architect and performance lead at Tag1. Fabian's one of the top Drupal 7 core branch maintainers. He's also one of the top 50 contributors to Drupal 8 and maintainer for several Drupal 8 core subsystems, including BigPipe, Dynamic Page Cache, and Theme API. We're also joined today by Michael Myers, managing director of Tag1, and it's a real pleasure to sit with you all today and to talk a little bit about some of these very exciting and cutting-edge topics. By the way, this session will be recorded and available on YouTube as well as on Tag1's website. So if you want to check out our past Tag1 Team Talks, please go ahead and navigate over to tag1.com/tagteamtalks. And if you like this talk, please remember to upvote, subscribe to our YouTube channel, share it with your friends and family. And with that, let's go ahead and start with a little bit of an introduction about Tag1 and why we're so interested in this topic.
Awesome. Thanks, Preston, Kevin, Fabian. Great to see you guys again. Collaboration is a big part of how we work together and get things done. And it's becoming a really important part of applications. And we're working on a number of collaborative applications right now that enable people to whiteboard together, create and edit shared documents together, and we think that this is going to be a critical part of a lot of applications moving forward. And the topic today, I think, is really going to accelerate the adoption.
I couldn't agree more, and I think that peer-to-peer collaboration is an incredibly relevant topic for so many enterprise organizations, as well as so many of us who work in content. And one of the things that we know now, that's a recent development, is that WebRTC, which enables this direct peer-to-peer communication, is now supported on browsers. But first, let's take a step back, and I want to ask Kevin and Fabian, what is exactly a peer-to-peer application, or what we're kind of terming these days a decentralized application?
Hey, so yeah, that's an awesome question. I think there are a lot of opinions on what decentralized means as an application. I think something that comes up more and more, and that is now really viable, is our applications that communicate directly with each other to maybe save some server load or to be more robust. And it's come up with WebRTC, which is now stable and supported by all the browsers. I looked it up just last year, mid last year. They released a stable WebRTC version, but even before that, it was well supported by all the browsers, and they can also communicate with each other. And yeah, it's basically the easiest way to create a decentralized application is now in the web, like in my opinion. And yeah, so I would classify everything that uses WebRTC to share data is kind of decentralized an application. There are also many frameworks that use WebRTC as an underlying technology to share and sync data and maybe even store data. For example, there's a DAT protocol, and IPFS to a certain degree also use it as this. So yeah, that's how I would classify it.
Yeah, for people who are not familiar with the acronym, IPFS is the Internet File System. Basically, it's a huge storage where the data of the world is stored across several different computers, and it's absolutely insane. It's like they have like a decentralized YouTube, where when you're watching a video, you're not getting it from Google servers or Amazon servers or whatever, but you're getting it from some computer on the world that has the data. It's really cool. But getting back to reality, one appliance for distributed peer-to-peer is what we're doing right now. It's conference calls, because no provider, not even Google or Amazon, would like to have that huge bill of having all the traffic routed through their server and then again to all 4 of us. That really doesn't make sense. So right now, we 4 are basically connected via a peer-to-peer connection between each other. Everyone is getting this feed directly in that, and this is basically one of the foundations for voice calling over the internet is peer-to-peer. And the nice thing, and that's what we're talking about now, is how we can utilize this technology in the browser in the context of Yjs for collaborative text editing, whiteboarding, etc.
Yeah, right. I think the main application for WebRTC at the moment is for creating conferencing solutions, right? So there's Google Hangouts, there's OpenPass, like there are many applications that use WebRTC, but only for sharing media data, like screen recording or WebRTC recording. And something that is not well known to a lot of people is that you can also share data with WebRTC, but there's something missing, and that is how you resolve conflicts. Because if you have many peers, you will have conflicts between the data that you are working on. So when you want to share data, you need some algorithm, some approach, some protocol to resolve these conflicts, or like decide what is the latest version. And Yjs supports is exactly built for that. Like if you haven't been on the latest talks that we did before this, Yjs is a framework for collaborative editing that is completely network agnostic. So you can, you can enable collaboration over any network. Is it your existing communication layer, or WebRTC, or simple WebSockets, or even a mesh protocol? That all works. And now there's a WebRTC provider officially supported in for Yjs. I've been working on this for quite some time, and yeah.
So one of the things I'm curious about is, because we've jumped right in and talked about Yjs, can we give a quick summary of what's a good definition for WebRTC, like the 1 or 2 sentence kind of purest definition that we can offer our listeners today?
Yeah, we should have done that before. Right? So to go back, WebRTC is a protocol that allows you, maybe not a protocol, it's a protocol as TCP is a protocol that allows you to create direct communication from one browser to the other. Basically, it works like TCP, but it has the advantage that it can punch hole through net layers, through proxies to the other side. So the problem that you are facing is you are in your local network behind a router, and you are behind an internet service provider, and now you want to create a direct communication to your friend, to you, to share media data or to collaborate on a document. And WebRTC is exactly that. It's a protocol on how to make that possible, how to punch the hole through the network, and how to establish communication that goes through these net layers. Yeah, it's kind of complex, but actually it is not. It's so the way this works is, as a client, you find out your external IP address and some additional information, and then you send this as a candidate on how you might be able to be reachable to the other peer, and that peer like decides, okay, is this an acceptable method for me to communicate? Can I do the same? Can we connect like that? Then this client finds out its own external IP address and some other information, and sends this as a session description to the other peer again. And if they decided that this is a way to communicate with each other, then they can create a connection to each other. And this is all defined in WebRTC. It's kind of complicated, but there are libraries that make this really easy and approachable. So yeah.
So what exactly do I need to do if I want to, let's say we do have two computers, we are across the internet, and now I want to communicate with you. So, and I know you have peer address, hey, great. But one thing, so I basically start the Yjs WebRTC, the WebRTC connector, and then I'm putting in your IP address. Would that be kind of, and would it be like some unique identifier how I would reach you, or that you generate for me to reach you, or how would it be?
Yeah, great question. Like, how can we establish a connection with each other? Like, we could define that I have a unique identifier, but in order to exchange session data, you need some other networking layer to communicate that session description, right? The external IP address, all these information that I talked about. And this is usually done by a signaling server. And the signaling server is not really a requirement. You can use any way to exchange these signaling data. For example, you could use email to send it. A friend of mine, Istvan Korint, he used QR codes to communicate the signaling data from one mobile phone to the other. It's really cool. He is a researcher at RWTH Aachen. And yeah, this is also a way to do that. And this is completely peer-to-peer and physically approachable. But most implementations use a server, a central server, to reach the other client, establish a temporary connection, exchange the session description, and then you have a direct connection between the peers, and the signaling server is not really necessary anymore. Sorry.
So one question I had is about security. I think with all this direct communication happening between these peers, once you establish that connection, there's some security implications there. Is WebRTC an encrypted protocol?
Yes, it's by standard, it's encrypted. So all the, it's non-optional. Every WebRTC connection that you encrypt is, that you create is encrypted by default. So it's basically a public, it's an biometric encryption protocol that is well known, and it's integrated in this in the WebRTC protocol.
And it uses public key cryptography. Was that what you were saying? Like, I sent you my public key via the signaling server, which we both trust, and then you can encrypt the data with it.
Yeah, right. But you don't really interact with the with your public-private keys. This is done by the browser. Usually, it is added to the session description data. So also, there's a new certificate that is created for every connection that you do, as far as I know. So yeah, within the information that I send to you to establish a connection, there is this certificate. And it is a requirement in order to establish a connection. So WebRTC is secure by default. But you said,
right. So you are sending me the box with which I can then send you the box back, and you have the key to open the data. That's cool.
Right, exactly. Right. We already do the all this product. We already sent the data back and forth, right? So we can just attach a certificate and it's secure. So why wouldn't we do it? But you said something interesting here. We both trust the signaling server. Yeah, so do we really need to trust the signaling server? So this is something that, yeah, that was interesting to me because I developed a signaling server that you don't need to trust. And this is also possible with, asymmetric encryption, which basically says if all the peers have a shared secret, some certificate maybe, they can communicate through the signaling server without trusting the signaling server, right? This is easily possible, but it's unfortunately not done by a lot of people. But to me, it's a really interesting concept.
And that's how Yjs works, is it can work with an untrusted signaling server?
Yeah, so the new WebRTC provider, it supports signaling through an untrusted server. Yeah, let's jump right into it. So WebRTC is the communication layer, and it provides a method to exchange signaling data through a very minimal, simplistic signaling server implementation. The idea here was that you can easily re-implement it in any other language. It's basically something like a publish-subscribe server. You basically send message to a room, and everyone who is subscribed to a room will receive that data. But the actual data, like the session information, it is encrypted with a key that only the peers know. So this is how you can encrypt the data without trusting the server. And for example, I provide several signaling servers that you can use for free. They are public. And usually this is a bad idea, right? But for this scenario, if you want to develop your own application, just get started. You don't have to set up your own signaling server. You can just use a default one. And it's also easily scalable because publish-subscribe servers are easily scalable.
So let me explain this a little bit more for people maybe less familiar with technology, security, encryption, and all those things. There's basically two ways, for example, Michael and me can exchange a secret message. We can both define a code word, like bird, for example, or Tag1, so that might be a little bit easy to get. And now with that code word, we can securely exchange a message. This is called a symmetrical encryption. There's another part of encryption, and that is public key cryptography, and you all use it because it's kind of how the HTTPS works. That means someone has a secret, and he's publishing the other part of that secret. I've already explained it quickly, but just again, it's basically I send Kevin a box. Kevin sends me a box to which only he has the key. But it's open, and I put my secret message in there, close the box, and now I send it back to Kevin, but no one else has a key, not even me. So once I've put this thing in the box and closed it down, no one can open it except Kevin, and that's basically the thing. The problem is now for the first part of how do we exchange things, and now one of the parts, and that was the first part of how a signaling server would be working, is that everyone would be saying, hey, my box or my public key is this, and they would be sending it to the signaling server, and the signaling server would send it over to the others. However, because it sits in the middle, he could as well say, hey, I sent my own public key, and this is a man-in-the-middle attack. So that's not what we want. So what Kevin, and now we can put this in a WordPress or Drupal context, is basically all of those editorial sessions are starting on a Drupal site, for example. So all of those sessions have Drupal, they trust it, they have HTTPS to that site, so we can generate a token. We generate the token 1, 2, 3, 4, 5. Not that secure, but anyway, we have the token, and all of them have the same token. They know it. The Drupal server knows it, but the signaling server does not know it. And what Kevin has done now is basically that we can use a signaling server, but the signaling server will never know our secret. So basically, we can now, as soon as we are connected, exchange data via our secret token that we got from Drupal, and we can use any signaling server on the net. And this is very, very cool because it solves a very, very common problem. The problem of, setting up your own signaling server, your small website, small CMS, etc., and not having to trust that server because our encryption is end-to-end encrypted, that's what it's called. We are directly encrypting our messages via the secret key we know and trust. We don't have to trust signaling servers, so anyone can set up the signaling server for us. And I think that's a huge win in that. And this could allow Yjs and others to be widely more used because you don't have to set up a node server, you don't have to set up a slow PHP with polling server, whatever for those initial connection to start. You just use any public signaling server, and once you're connected, you're secure.
Right. And again, you said something interesting here. This was a great explanation of all the concepts here that you can use just by using a secret server, a secret key. You can make sure that only people who have real access to the document can actually read it. And you said something interesting here is to one of the signaling servers, because this is something I want to talk about. With WebRTC, you can access many signaling servers at the same time and just find people on one of these servers. So if two people are connected to the same signaling server and they are accessing the same room, they can now, they will find each other and create connection with each other. An advantage of this is you can use this to scale your server or your signaling signaling servers by setting up many signaling servers. And if you want to connect to a specific room, you are going to use one of several specific signaling servers. So these servers don't really need to communicate with each other. More, this is set to the client side now. The client decides which signaling server they are going to decide to use. And yeah, this allows you to not set up some complex server environment where you need to have Redis or a pub/sub node that is that you need to scale to many instances if you have a large application. Now you can just connect to many signaling servers, and hopefully one of them is reachable by all the clients. And yeah, this is how they are going to exchange their data.
That's really wonderful. And you know, one of the things I did want to call out is that WebRTC is something that, you know, as you mentioned, Kevin, has been historically used primarily in conferencing solutions, but it's also used in places like WebTorrent, you know, DAT protocol, some of these really interesting peer-to-peer technologies. But I guess I'm really curious about one thing. You know, we've talked a little bit about how signaling and why WebRTC works. Is there any sort of maximum number of peers, or what are some of the limitations of why WebRTC, and how many peers, or how much, you know, how many people can be connected at the same time?
Yeah. Yeah, so what happens when you create a session between many peers? They all connect to each other. So naturally, this might be a huge network. So if you have 20 people that are working on the same document, you are going to connect to 20 people, and there are going to be a lot of connections. It is completely fine if one of the connections fails, because the document updates are going to be forwarded through all the peers as long as this network is connected with each other. So something that you don't want is that this network is going to be split into two networks, but both networks are connected to the same room. So this is something that you want to avoid, because then you are going to fragment your document. This is why by default, all the connections are just connected to each other. This is the simplest solution to that, and it usually scales well and easily up until 20 or 30 peers or so. On a mobile device, it might be even less, because doing that on a mobile connection might impose some more restrictions. It might be slower, but all you need is one peer that is connected to all the other peers, and then you're going to receive all the data. So I would say, like, don't plan to have more than 20 or 30 connections for WebRTC. This is basically the limitation. Maybe in the future we can optimize that, but I'm not sure. Because you need to make sure that all the peers are somehow connected with each other.
Speaking of connected all to each other in Partition, that's an interesting question. So let's say Michael is in America, we are here in Europe, and Michael is communicating with all his other, his whole marketing team and we are also collaborating together. So we are collaborating together across the ocean. And now someone cuts that huge cable there for a moment, or a fish is having a bite, whatever. So now we have like this partition where they are working on the document, we are working on the document, but we are no longer connected. Even if we are all connected to each other, we are no longer connected. So how would Yjs deal with that once the connection is established?
I'm sorry, can you repeat that question? Like the problem that occurs in this
The
scenario?
problem is basically the network partition. There's 3 people in America and 2 people in Europe that are working on things together. And so now you make updates, I make updates, we each see our updates, obviously, and they also make updates and they all see their updates, and now we get reconnected because the cable gets fixed. How does Yjs deal with that case?
Oh, okay. Yeah. So as soon as one client from one partition connects to the other client from the other partition, they are going to sync their content with each other. This is what Yjs is all about. It can sync everything. It can always sync. If you partitioned like a lot, in America you created like this huge document, and in Germany we created like a different document that looks very different and has different typos, then you're going to sync, and this sync might not make a lot of sense. So you want to make sure that the timeout between when the fragmentation is solved is not too long. Otherwise, it might be really weird if at some point, oh wow, there's a lot of content apparently, but it will just sync as soon as the petitions are somehow connected to each other.
Is there like a problem when, for example, I mean, we both are here in Europe, and then I sync all of my guild changes, and you also sync all of my guild changes, but I'm a little bit quicker with syncing my changes, and then I'm sending my changes that I've synced already to you already. Would it give like a sync storm or something? And how do you avoid that?
Yeah, that's a good question. Like for Yjs, it's actually not a big problem. So obviously there's a lot of data that might be transmitted. So when you have 2 huge petitions, like 10 clients on the one side and 10 clients on the other side, and then you just receive 10 clients at the same time, and you sync with 10 clients like synchronously, well, you will receive the same data 10 times, but Yjs will recognize, okay, this is a duplicate of the content that I already received, so I don't have to apply it to my document. And this is something that is very important, because you will receive duplicates all the time. Even with using the WebSocket connection, every time you make an update, the server will send the update back to you, or another client that is somehow differently connected will also send the update to you. But because each update, or like each character, we talked about this before, is uniquely identified, we always know that, okay, I received this character, but this ID is already defined, so I can just throw it away. I already applied the update, right? So that's no problem.
Cool.
Kevin, is this peer-to-peer cap specific to collaborators? So for example, let's say, you know, we're editing a document together as a group and we have 40 people. Can it be 20 people that are editing and 20 people that are just watching? Like, is there a cap on the number of watchers?
No, it's so they all should be connected to each other. So it's not like that. In Google Docs, I know it's exactly like that. You can have like 10 or 20 collaborators on the same document, but if you have more than that, there's a fixed number. If you have more than that fixed number, they can only view the document until a certain degree, and then even that breaks up. Then you can always see updates on the document, like flashes of content. So this is how it was like 2 years ago when I checked this. So in WebRTC, this would be the same until a certain degree, and then you might get into trouble because you shouldn't have too many connections open. At some point, the browser will say, okay, I won't take any more connections. I think at 120 connection or so in Chrome, at least, it will just say, I can't accept any more, and it will throw errors. But if you are lucky, the connections are still somehow alive and there's no fragmentation. So this will still work. Although it is not recommended. If you really want to have a huge number of collaborators, you should use a central server or some other approach for that. For example, WebSocket really scales well with a lot of users. You can also optimize this, just use WebRTC until the cap of 30 users and then maybe connect to a WebSocket server. But yeah, this problem hasn't been solved yet.
So I would think for most use cases, 30 active collaborators is sufficient. And like you said, if you do have a case where you need a large number, you can always fail back to a centralized server model for that specific instance.
Yeah. Also, it of course would be possible to have a different algorithm for viewers. It would be additional work and it's not implemented right now, but if someone really wants to do it, no one would stop him from just having a signaling server which allows to select any peer and just listen to the updates this peer is giving basically. And because every update is sent to everyone, you can just listen to any peer, and then you have like 20 people actively collaborating, and then every one of those has one additional connection to one viewer. So that's definitely, and if connection gets lost, obviously you need to select some other collaborator. So it's technically possible, just not implemented.
Right.
So like just for clarification, this is on a single document. So let's say I'm a large media company, like a newspaper, and I have lots of authors writing lots of documents. Each individual document can have 20, 30 collaborators. So as an organization, we could have hundreds or thousands of people collaborating simultaneously on different documents. It's just a single document cap of that.
Right, exactly. Like this is only limited to the same document. And usually this is enough. You don't want to collaborate with more than 30 people. This won't be productive.
Also, if you are a really huge media company, I guess you might perhaps have some money for a few Node.js servers.
That's true. I mean, WebRTC is, it's really cool, but if you really want to have secure connection, if you really want to make sure that the clients are able to reach and share their data, you want to use WebSockets, right? But if you're interested in using serverless applications, like you don't really need to set up anything for this collaborative approach. If you want to have collaboration as a drop-in feature for your product, use WebRTC, because why not? Because before it was non-collaborative, and now you have WebRTC support in all browsers. It will, like most of the time, it will just work. And if you run into troubles, you have too many features, it's still better than having no collaboration at all, right?
Yeah.
So the majority of Drupal users or WordPress users are the long tail, millions of websites that are run by individuals. So the power of this is that, if Drupal or WordPress were to support this as someone with, a personal Drupal site, I could have collaboration with peers without having to add any software to my application. It would all be included in the distribution. So that's what this enables?
Yeah.
Yes, exactly. This is exactly what this enables. So basically it works like this. You download a Drupal module, you have the special editor that Yjs enabled. As we've talked before, you need a special editor for it. For example, Mirror, for example, others that are available right now. And then you basically just enable this module, use one of the public signaling server, which you would configure in the module. And basically, you would start your document, it would connect to the signaling server, and someone else would also open the same document, connect to the signaling server, and it's all working. Because after the signaling server has connected us to, there's nothing more for it to do, and we would be collaborating like if we had a central server. So yeah,
that's pretty mind-blowing. I mean, literally any CMS or any type of application out there could implement this very quickly with minimal overhead.
Right. Yeah, I mean, this assumes that this public server is is always available. I would be interested in setting up an organization to just scale these public instances so we can have more users that support that. Another option that we might want to take is like if we might be able to implement the server implementation in other languages like PHP. That would be really interesting to me. Just support this signaling in the server directly. Because the signaling server at this time, it's 100 lines of code, right? You can easily do that in any language. Just re-implement the approach, and voila, you can have the whole approach, like the signaling, collaboration, everything on your side, and it will also work in intranets. And if it doesn't work, it's still better than before.
I think this is a time where CGI bin/Perl will shine again. No, just kidding. Actually, for things like PHP, there's techniques available to make a signaling server, for example, long polling, where you're basically using one connection very long, and as soon as data arrives, it gets written to. You can also use frequent polls, which works amazingly well with things like Vanish, for example, or Akamai, or any CMS Fasti. Also, it's an amazingly efficient way to keep load of the server, because as soon as your data expires, and there's, for example, a new client, you just expire it, and it gets fetched once by the server. And so polling is actually way more feasible than it was 10 years ago. As soon as you use something like Varnish, Fastly, even Cloudflare on its more advanced tails, etc., because you can really even Cloudflare normal would work, because you just need cache tags or cache invalidation, and you basically can have the clients poll every 10 seconds, every 1 second. Is no big deal for all of that, and the server will just get one request once the data expires. And that's a very, very cool way to implement polling today in 2020. That is actually not as well used, because many people kind of like said, oh, polling is bad, it's bad, it's bad, it's bad. But it works amazingly well as soon as you put a CDN on it. So that's another alternative. Just have a very simple PHP client, push some CDN before it, and expire the cache as soon as the data updates, and you will have almost real-time signaling without any overhead on the server.
Right.
We should write a blog post about that. This is cool.
Yeah, that would be interesting. I mean, there are so many ways to scale that. I would be interested in exploring this whole field. I mean, I just want to say WebSockets are also supported in PHP, I hear here. But long polling is also a very viable option. I know that a lot of applications, a lot of software prefers long polling instead of WebSockets. Another thing that you could do is, somebody brought that up in the WordPress GitHub organization, I think. You could use the pings that you always send to the server to, like when you open a Gutenberg site, for example, you send pings in intervals to the server. Something that you could do is you could make sure that if a client wants to connect to you, you just append some information like the session description information to this ping, right? Just leverage the ping and add some information to it, because that's something that you do anyways. So why not combine that?
Yeah, definitely. But as I said, short polling is also very viable.
Yeah.
In that, and always it depends also on your mileage. Like, because this polling approach is only used for the active documents where you are actually on, Basically, even if you ping every second, but you have a largely scaled server somewhere, it might not even matter in the whole wheel of things, because really you only if you're really editing a document will this polling happen. And who cares if there's a ping every 5 seconds? For 2 users or 3 users or even 30 users, that's not a big problem. The big problem with polling and all those things, and where then the WebSockets really shine, is when you have thousands, 10,000s, 100,000 of users, where polling and long polling really does not scale anymore.
Right, that's true. I mean, and if that doesn't work anymore, if you really have a huge application, if you really need it, you can always switch to any other protocol. So this should be supported, like use the WebSocket server if you really need it. And it should be easily scalable, right? So yeah, many opportunities, everything is exchangeable, and it's a perfect drop-in replacement, drop-in feature if you want to enable collaboration in your application. It's always better than before, like in my opinion, it's better than without collaboration. Another thing that I want to bring up is here the mesh support. I think we talked about this sometime. Yjs collaborates, like exchanges document updates using a broadcast channel, which is a browser API to communicate to other tabs. Something that why WebRTC does, it manages these connections to the other tabs. And if you have this in another tab, you won't create another WebRTC connection to the other tab. So this is one of the cool features. You can also combine this by using other Yjs providers. For example, if you want to have WebRTC, and then at some point in the middle or at the beginning of the session, you decide, I also want to use another protocol, for example, YDAT, which is support for the DAT communication layer, or if you want to use WebSockets, you can also support WebSockets and share your data over peer-to-peer WebRTC and WebSockets and the DAT protocol, and just hope that anything of that works. So this is another new feature that I implemented, that all of this is meshable. I would be interested in supporting Bluetooth connections too, just for the heck of it. If you find, if you open your phone and you want to collaborate, the first thing that you could do is query if there's another device that supports Yjs and exchange the data using Bluetooth, because why not? It's meshable. And it will also work while you are not connected to the internet anymore, because it's Bluetooth, it works locally, right? This might be awesome on conferences where I had this one conference where I wanted to show Yjs, and of course it failed because there was no connection, or it didn't work because we didn't have the bandwidth to support all these devices, like 150 people accessing the same server through the university network. So I thought, man, it would be awesome if there was some physical way to transmit the data. And looking forward to Bluetooth, peer-to-peer connection through Bluetooth coming in 2021, but lots of opportunities here. Yeah.
Wonderful. Well, we are just about out of time here, and I want to say, first and foremost, thank you so much to Kevin and Fabian and Michael for joining us today. One quick last thing, Kevin, where should people go if they want to learn about why WebRTC? Is there a demo available of this as well that we can try out and play around with?
Yeah, go to yjs.dev. There's several demos. The website uses WebSockets and WebRTC now. I just do that to find out how many peers I can support with WebRTC. So just open it on a lot of devices and let's see what happens. Another thing, go to the GitHub repo, github.com/Yjs. It's the Yjs organization. find out about all the connectors that we support, all the editors that we support, and yeah, I'm looking forward to more Tag1 talks, especially look at the first 2-3 Tag1 talks about collaboration using Yjs to find out more. And please ask any questions in the discussion board, discuss.yjs.dev. There are some people and helping you out if you have any questions, any suggestions on the website. You want to see a specific application, you have an application developed and you want to show it off, please post it there.
Wonderful. Well, thank you so much. And just as a reminder to our audience, thank you once again for joining us for this Tag1 Team Talk. Tag1 Team Talks is the series about emerging web technologies consisting of webinars and podcasts about some of the most fascinating technologies on the bleeding edge of the web. By the way, we post all of these talks at tag1.com/tagteamtalks, and all the links we mentioned today will be included and posted online with the talk wherever you're looking. And if you like this talk, as with every single Tag1 Team Talk, please remember to upvote, subscribe, and then share it with all your friends and family. As always, we love your feedback and any suggestions. If you want to hear about a particular topic, if you want to bring Kevin back, if you want to bring Fabian back more often, we'd love your topic suggestions. Please write to us at tagteamtalks@tag1consulting.com. Once again, a real fond thank you to Michael, Kevin, and to Fabian. Always a great time to see you and to hang out. And I'm looking forward to the next one of these as well. Take care. Thank you.